Okay, I'm going to use a thick yellow. Okay, blood enters the right atrium right here through the superior vena cava, the inferior vena cava, and the coronary sinus. So blood enters the right atrium through the superior and inferior vena cava and the coronary sinus. Blood travels through the tricuspid valve into the right ventricle. Blood goes from the right ventricle through the pulmonary valve, up, pulmonary artery to the lung. From the lungs, it goes through the pulmonary veins to the left atrium. From the left atrium, it goes through, blood goes through the mitral valve or bicuspid valve into the left ventricle. From the left ventricle, it goes through the aortic valve, which you can't see on the picture, and up the aorta. Okay, real quick, we've covered 4 chambers. We covered the right atrium, we covered the right ventricle, the left atrium, and the left ventricle. And that's the order 1, 2, 3, 4 that blood goes. It goes 1, 2, lungs, 3, 4, out the aorta to the body. Okay, we covered 4 valves. The tricuspid valve and the bicuspid valve. You see, because it's got the 3. 1, 2, 3, and just 1, 2. Anyway, they both have chordae tendineae. And there's that word right there, chordae tendineae. It's like a basketball hoop, kind of, that opens and closes nicely. That's 2. Those are what we call AV valves because they go from the atrium to the ventricle. Now, we covered 2 more valves. We covered the pulmonary valve here. It's a semilunar. It does not have chordae tendineae. And we covered, you can't see it, it would be right here on the bottom of the aorta, the aortic valve. So it'd be like up in there. And it is also a semilunar valve. So 4 valves, 4 chambers. And if I were you, I'd go back and pause the video and rewatch that part. Make sure you get that down pat. And that's the pathway of blood. Okay, so there's a picture of the valves. You'll see that. There is a description of each valve. And you do want to point out, I pointed it out, but let's make sure you know that the tricuspid and mitral valve both have the chordae tendineae. Right? They are what we call the AV valves, and they have chordae tendineae. So make sure you got that. And you can see the chordae tendineae there. That's what that is. There's the flow of blood through the heart. Let's take a second and look at this. Okay, you'll see from right here where it says pulmonary trunk all the way to pulmonary veins. That is the pulmonary circuit. So okay, right here, just pointing this out because you want to study that right there. That's what we just went over with the drawing. The mitral valve is also called the bicuspid valve. So either one are acceptable. Okay, and then I do want to point out something right here. Most arteries are red because an artery goes away from the body. So artery away from the heart, I'm sorry. Artery goes away from the heart. A vein goes towards the heart. Okay, so watch this. The aorta right here, aorta away, 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 away. Then it turns into veins. Back towards the heart, back towards the heart, back towards the heart. So you'll see from just that little loop I did, arteries are red and veins are blue. Generally. Arteries are red, always actually, and veins are blue, except, always except, right here, the pulmonary artery and veins. Okay, remember, arteries go away. So this pulmonary artery goes away from the heart. This pulmonary vein goes back towards the heart. But they're the opposite color. So the pulmonary artery is blue. The pulmonary vein is red. So just study that. Make sure you got that down pat. But look over, this is the flow of blood through the heart. So I did it with a picture. I'm very visual. But for those of you who are not visual, look at the words and kind of go through it. And go through it both ways, because you want to know the way that blood goes through the heart. Okay, like we said, the heart is a muscle, so it's got to have oxygen. And so the coronary arteries, you can see them here in this picture, they carry blood to the heart, like to the heart muscle. And sometimes, just sometimes, those will get blocked with clogged arteries. Those will get blocked with, high fat or cholesterol or whatever. And that could cause a heart attack. And so that, when the flow of blood, when it slows down, it causes pain. And if it were to become blocked, it could cause a heart attack. A myocardial infarction is a heart attack. Okay, so let's look here. I want to point some out for you. This is the outside of the heart. So we looked before at the inside, but this is the outside. I want to point out specifically the anterior, there we go, anterior interventricular artery. Okay, so where that is, right here, it goes enter the ventricles, I-N-T-E-R, in between. That means in between the ventricles. And it's on the front, so it's anterior. On the front, in between the ventricles. That, a lot of times, if that gets clogged up, it could cause someone to fall dead immediately. And we call that, so you want to write all this in, we call that a widowmaker. It's more common in men. Sorry, guys. Left anterior interventricular blockage is called a widowmaker. And so what it supplies blood to the ventricles. So it goes right down the ventricles and supplies blood to both ventricles, and it's bad if it's blocked. You can see there's an angiogram. Isn't that cool looking? I just think that's the coolest picture. Okay, the cardiac cycle. What happens? You've got, it says this is how the heart beats. The heart chambers function in a perfect manner. Lub-dub, lub-dub, that's the sound they make. Heart actions are regulated so that so you want to highlight this, so that the atrial systole, while the ventricle relaxes. So the atrial contracts. So just maybe by the way, the word systole means contract. And the word diastole right there means relax. Okay, so the atrium contract, or atrial systole, while the ventricles relax, or ventricular diastole. Then ventricles contract while the atria are relaxed. So it's like the atrial relax and the ventricles contract. So they're opposite. So that way it just flows perfectly. Okay, so here it is a little more detailed. During atrial systole, contract, ventricle relax, what's happening? So I don't want you to memorize this. This is on the test in multiple choice form. I don't want you to memorize it though. I want you to understand it. So highlight all this. Okay, so think about it. When the atrium, so here's your heart over here. Think about it. I'm visual. When the atrium contracts, so these right here are contracting, the ventricles are relaxed. They're opened up. When they relax is when blood fills in. So think about it. When the atrium contracts, the blood can flow passively into the ventricles. The ventricles are relaxed. The AV valves, so the AV valves open. That's tricuspid and bicuspid valves are open. The blood flows passively into the ventricles. And then on the other one, when the ventricles flex, what happens? Well, it doesn't go back Look, it doesn't go back this way. No, no. No, from here, we're going to the lung, and from here, we're going out to the body. So, the AV valves close, the chordae tendineae are tight so that nothing can flow back. We don't want to bulge back into the atrium. The atrium are relaxed. Blood flows into the atria from the vena cava and pulmonary vein. So, blood flows into the atria. The ventricle pressure increases and opens the semilunar valve. So, the pulmonary valve and the aortic valve are open. Blood flows into the pulmonary trunk and the aorta. So hopefully, take a second, make sure you got that. This is a small flex. Just going down to the ventricle. This is a big flex going out to the lungs and out to the body. Okay, this is just something that the book included that I thought was interesting. A heart transplant, the LVAD machine, it says a mechanical half heart used in some cases until the heart donor is available. They use that all the time on Grey's Anatomy, so I'm all up to knowledge on that. An implantable replacement heart, and so they can use plastic artificial heart used in people that cannot have heart transplants. They don't have long to live. And then stem cell technology, they're making, valves and things like that with stem cells. So that's all interesting. Okay, what kind of sound does it make? It makes a lub-dub sound. Lub-dub. And so the first heart sound occurs when the ventricle systole or contract. The dub, the second heart, occurs when the ventricles relax and they fill up with blood. And so lub is actually a small sound and dub is a big sound. Now I want to point out a murmur. A murmur is an abnormal heart sound derived from incomplete closure of the cusp of a valve. My husband has a murmur, so I'm going to ask it on the question. He has to take an antibiotic before he can go to the dentist in fear of the endocarditis. But his heart sounds like lub, lub. The dub is not hard. I tell him that all the time. But there's different kinds of murmurs and different sounds that murmurs can make. But oftentimes, it can be caused by endocarditis. He was born with his. Okay, so this is just a picture showing you where it says where the aortic area is, tricuspid area. One thing I didn't mention that I want to mention, when that mitral valve doesn't close properly, I thought it was in there somewhere. Hang on, let me see if I can find it. Oh, well, when the bicuspid or the mitral valve doesn't close properly, the blood will bubble back up into the atrium. And normally the mitral valve prolapse, their heart is still functional, the valve is still functional, but the blood will bubble back into the atrium. And so that's another heart condition. Okay, how does this all happen? It's like electricity. It's the coolest thing ever. Electricity flows through the heart. How? Do you remember from 201 that the cardiac tissue had intercalated disc? Anyway, well, it's like the electricity can spread out through it. And so a syncytium is the electricity in your heart. Cardiac muscle fibers form a functional syncytium. Isn't that a fun word? A mass of merging cells that function as a unit. So it's the electricity going through. You got special muscle fibers that actually conduct this the cardiac impulse, starting with the SA node. And so it says two such masses exist in the atrial walls called the atrial syncytium and the ventricle syncytium. So let's look at both of those. Okay, so here's how the electricity flows. And I'm actually going to move on to the next slide. But first, the SA node, right there, that's how it all starts. The sinoatrial node starts it all, it indicates the impulse, and that's what we call the pacemaker. So you want to know that, write that in. That's the pacemaker. If yours doesn't work properly, you have to get one put in. The SA node is in the right atrial wall. So let me show you this picture. This is better. Okay, so do you see where the number 1 is? Yeah, that's where, okay, so that's where it starts. Right in the right atrium, so make sure you know that the SA node is in the top right atrium. And then it flows down to number 2. And that's going to be the atrial syncytium. The atrium is lit up. It's got electricity. Okay, and then it's going to go down. It's going to go all the way. That's the atrial syncytium. It's going to go across. And now it's going to go in between the ventricles. Atrioventricular bundle. So atrioventricular bundle, or AV bundles. That's what I always heard of, AV bundles. Okay, then as it goes on down, those are called bundle branches. Those are bundle branches. And then as it goes up, they're Purkinje fibers. Purkinje fiber. So you'll want to look back at that last slide at the order, and then also look over here. But you definitely want to know that the SA node is the pacemaker, and this functional syncytium is on the lab exam. Okay, EKG or ECG, and we know it's an electrocardiogram. That starts with a C, but in Germany, the K comes from Germany. Something like the cardiac starts with a K. Okay, you got different waves, so highlight what it is. An EKG is a recording of electrical changes that occur in the myocardium during the cardiac cycle. It's used to assess the impulses, so you're actually measuring those impulses. And there's the P wave, which happens when the atrial depolarize, which is like right before it contracts. That means electricity reaches the atrium. That's QRS wave is big. That's when the ventricles depolarize. And then the T wave is when the ventricles relax. So resting. Let me show you this here. I know, it's a nice drawing. Okay, so there's your first one, your P wave. That's depolarization of the atrium. So the nerve impulse reached the atrium. Now it's going to flex. This right here is the QRS wave. That's big. That's ventricles. So it makes sense that the P is a little hump and the QRS is a big hump. And then the T is just the rest, and then you can start again. This over here is not included. That's a U wave. It may or may not show up on the EKG, but it's just repolarization of those Purkinje fibers that go up the ventricles. And so that way, kind of look at this in comparison to the description. Okay, I found this on YouTube. I want to show it to you.
The heart is a muscle about the size of your fist. It lies behind and to the left of your breastbone or sternum. The purpose of the heart is to pump blood through blood vessels, arteries, and veins to all parts of your body. The inside of the heart is divided into 4 chambers. The top 2 chambers are called the atria and are collection chambers for blood. The bottom 2 chambers are called the ventricles and receive the blood from the atria and pump it to the lungs and the body. The chambers are separated by valves which control the direction of blood flow. There are 4 valves: tricuspid, pulmonic, mitral, and aortic. Circulation begins at the right side of the heart, where blood from the body comes to the right atrium. This blood passes to the right ventricle, where it is pumped to the lungs to receive oxygen. Once it receives oxygen, it flows to the left atrium, and then to the left ventricle, where it is pumped to the aorta and the rest of the body. On the right side of the heart, the tricuspid valve separates the right atrium and the right ventricle, allowing blood to enter the ventricle, but not flow backwards to the atrium. Blood flows through the pulmonic valve to go to the lungs. On the left side of the heart, the mitral valve separates the left atrium and the left ventricle. Blood flows from the left ventricle to the aorta through the aortic valve and to the rest of the body. Arteries carry blood with oxygen and other nutrients throughout the body. Veins take blood back to the heart, which pumps it to the lungs to be oxygenated. The heart arteries coronary arteries, provide oxygen and nutrients to the heart muscle. The right coronary artery supplies blood to the bottom and the back of the heart. The left coronary artery splits into two vessels. One branch supplies blood to the front of the heart. The other branch delivers blood to the left side of the heart. An electric system transmits signals throughout the heart to control its pumping. The electrical signal starts in the sinoatrial, or SA node, which is located in the upper portion of the right atrium and is known as the natural pacemaker of the heart. The electrical signal passes down to the lower chambers of the heart via the atrioventricular, or AV node, which controls the signal so the atria contract before the ventricles. In the ventricles, pathways carry the signal throughout the muscle so that they contract at the same time to pump blood to the lungs and through the body.
Man, wasn't that good? I'll link it for you so you can watch it if you want again. And you might not could hear it good. I don't know. Anyway, the SA node so what controls the heartbeat? We know the SA node is that pacemaker, but there's some other things. When you exercise, heart rate goes up. Body temperature, heart rate goes up or down if your temperature goes down. Fight or flight, so the hormones. Okay, highlight this. The baroreceptor reflexes arise from cardiac control center in the brain in the medulla oblongata of the brain. Balance, start and stop, inhibitory and excitatory effects of the parasympathetic and sympathetic fibers. And so the brain, as well as hormones, control the heart. Okay, just some interesting stuff. Arrhythmias, that's when the rhythm is not perfect. Lub-dub, it may be too fast or too slow. And so look at those vocabulary words. Fibrillation, just random, chaotic, uncoordinated. Tachycardia, fast. T-A-C-H-Y means fast. Brady means slow. Bradycardia, you got a flutter. Premature beat, just a little beat before the lub-dub. Ectopic pacemaker, that would be on the outside. Damage to the SA node may lead to AV node taking over. And then artificial pacemaker, we know what that is. We talked about an artificial AV node. Okay, so we already said arteries carry away. Veins carry towards, but the arteries branch off into thinner arteries called arterioles. Capillaries, now that's where the gas exchange occurs. That's where the oxygen is dropped off at the pinky toe and CO2 is picked back up. It also occurs in the lungs. The CO2 is dropped off in the lungs, oxygen is picked up. Okay, angiogenesis. Genesis is the beginning, so we know that. It's a formation of new blood vessels. And I've read before about people who have tumors, and how are those tumors fed? The tumors have to have oxygen and nutrients, and the body will actually form arteries to feed the tumors, which is unfortunate. But this is not talking about that. Angiogenesis is mainly controlled by vascular endothelial growth, but this is talking about when an artery is blocked, the VEGF is secreted to make new arteries around the blockage. So, may be able to be delivered in time-release capsules. So, preventing angiogenesis for tumors secrete that VEGF to nourish themselves. And so, you can prevent it, but it's also good if it goes around the blockage. Okay, there's an arteriole. They're smaller than arteries. Smallest arterioles have only a few small... You can see those rings around them. Those are muscles. So these arteries have these muscle fibers and they flex, which would squish the blood down. And so the speed in the artery is directly related to the heart pump. Muscles may impact blood flow, so those little muscles impact it. And then capillaries don't have those muscles. Here's the capillaries. Okay, on the capillaries, highlight that they are semi-permeable. But you want to know that's where gas exchange occurs. And they've got these little sphincters, these little openings and closings. And so, just to kind of make sure you got it, from the heart, it goes out the aorta, artery, and then the artery starts to split off into what we call arterioles. And then the arterioles split off again into capillary. So right here, this is the capillary, where the smallest artery becomes a vein. But that's where the oxygen is dropped off. So capillaries is where gas exchange occurs. Write that in. Gas. You might say it up there. Gas exchange occurs. Okay, capillary blood flow, we already said it, let's highlight it, has these sphincters, opens and closes. So you can see the sphincters in the picture. Capillary sphincters may close capillaries, and it's going to respond to cellular needs. So let's say you're doing squats, and you're using your leg muscles a whole lot. Well, you're not going to carry excess oxygen to your biceps. It's going to keep on going and go down to the legs. The metarterioles, M-E-T-A, that means in between. They're branches from the arterioles that can actually bypass. So look at the picture over on the right. You can see how it bypasses the capillary and goes straight back to the vein. Okay, veins. They're different. They don't have those muscles. So they don't have those sphincter muscles like the other ones did. The veins, the thinner walls than arteries, they carry blood under relatively low pressure, and that's why we measure blood pressure in the arteries, by the way. Function as low reservoirs, and they have these valves. So highlight, they have valves. Right there. Okay, so, I have all this highlighted. They are, the speed of the blood in the veins is not a direct relationship to the heart action. So as the blood flows, the heart pumps and pumps it down the arteries. It's these valves that push it back up to the heart. So it's not a direct result of heart pump, of heart action. Okay, this will just show you where the blood is, and we wrote it at the very beginning that most blood is in the systemic veins. Look how much. Okay, and you want to look at this. Only partially a directive heart action, so not directly. Also dependent on, it's got these skeletal muscles on either side. Breathing movements and vasoconstriction of veins. Okay, a couple of disorders. The first one, arteriosclerosis, and that's going to be high cholesterol. Unfortunately, we have a poor diet. We eat lots of bacon grease, and I saw a thing one time that was said, we won't pour bacon grease down our sinks, but we'll eat it. I'm like, well, that's true, because it'll clog up our sinks, but we're not worried about clogging up our arteries. An aneurysm, a bulge in the wall of an artery, formed when blood pressure dilates a weakened area of the blood vessel. It can burst. Okay, blood pressure. The force of blood, and we always measure the arteries, that exerts against the inner wall of blood vessels. Blood circulates. The term blood pressure most commonly refers to systemic arteries. Of course, there is pressure everywhere, but we're normally talking about arteries. Okay, it rises when the ventricles contract, falls when they relax. Okay, so there's systolic pressure, and that's the maximum pressure reached during the ventricle contraction. Diastolic pressure, the minimum pressure remaining before the next ventricle contraction. And 120 systolic and 80 diastolic is supposed to be normal. Okay, the pulse pressure, that's the difference between the two. And then the mean atrial pressure, that's the average pressure. So highlight, you want to know that normal is 120/80. And it's stated in units of mercury. That Hg is mercury. How do we measure it? With a sphygmomanometer? Tell me that's not a fun word to say. Sphygmomanometer? Commonly called a blood pressure cuff. Maybe a little bit easier to spell. But that is a question on the test, so make sure you know sphygmomanometer. Okay, and that'll just show you the difference in the systemic blood pressure and the distance from the ventricle. There's where. So how do we check the blood sites for measuring the pulse? That's where we check pulse. Okay, this picture shows you things that increase the blood. So blood volume, heart rate, stroke volume, blood viscosity. That's the next slide. That's how thick it is. And then peripheral resistance increase. Okay, viscosity is the difficulty with which molecules of fluid, so think about like a ranch dressing has more viscosity than water. So how thick it is. The greater the viscosity, the greater the resistance. Okay, hypertension, that'd be high blood pressure. Smoking causes high blood pressure. Stress causes high blood pressure. So it says long-lasting elevated atrial blood pressure. The causes are unknown. Oops, I just told you some things that caused it, didn't I? Increased sodium intake, so too much salt. Physiological stress that activates the sympathetic nervous system. Obesity, kidney disease, but this could be a silent killer. You may not even know you had it. Swelling is one of the symptoms. But all you really want to know is the word, that hypertension means high blood pressure. Okay, what does exercise do? And I'm an advocate of exercise. It's my happy time. So exercise is good for the heart. Your heart is a muscle, and we got to work it out. But it has to be a regular part of life. Cardiovascular system adapts to aerobic exercise. So this just tells you some facts about exercising. And it's interesting to know that someone who exercises actually has a slower pulse or heartbeat. And the reason is because the heart is stronger. It can pump more blood with each pump. So increased pumping efficiency. So the more you exercise, your heart has to work less. It doesn't have to work as hard. Okay, and the coronary artery disease, disease involving high cholesterol. I always think about bacon grease having high cholesterol. So, of course, lots of other things do too. Okay, I want to point out the rest of the PowerPoint is really just a lot of pictures, and of the arteries and veins. And I want you to look over all of them, but I want to point out some specifically. On this slide, I want to point out the brachial artery. That's the large artery in the arm. You want to know that for the test. What's the major artery in the upper arm? It's going to be the brachial artery. Okay, I want to point out, oops, and I think you know most of this. This is going to be on the lab PowerPoint that we'll go over, but you want to know most of these things, and I think you do know them. That's a nice picture. I do want to point out one, though. What artery takes blood to the reproductive organs? It's going to be the gonadal artery, like gonads. Okay, important, really important, is the common carotid artery. That's what takes blood up to the brain. That's important. And there's some veins. And I'm going to go over all this for lab in a different video. These are some of the symptoms as you get older. So cholesterol is going to be higher, smaller coronary arteries. The heart may shrink a little bit, tighten, or enlarge due to disease. And so just look over all those. But that's what happens as we get older in the system. And I hope that was helpful.